Hello and welcome back to this video series on higher chemistry calculations. In this video we will be looking at atom economy calculations. Atom economy is a measure of the proportion of a reactant included in the final useful product and tells us how green or environmentally friendly a process is. A high atom economy means that lots of reactant is used to create the desired product, i.e. we have an efficient process. Atom economy and percentage yield calculations go hand in hand in chemistry. A reaction may have a high atom economy but a low percentage yield, in which case it is not profitable and therefore would not be carried out. Now let us look at how atom economy calculations are carried out. Here we have the equation needed to calculate atom economy. Atom economy is the mass of the desired product divided by the total mass of the reactants times by 100. Question 1. Which process is the more efficient in the production of methanol? Here we have two processes by which methanol is produced from methane. Process 1 involves the steam reforming of methane, and process 2 is the incomplete combustion of methane. To be able to work out which process is more efficient, we must calculate the atom economy for each process. To do this, we have to work out the mass of our desired product and the total mass of the reactants. We do this by calculating gram formula mass using the arrow method as learned in National 5. Here we have our desired product, methanol, and to work out the desired mass, we simply calculate gram formula mass. We have 1 carbon with a relative atomic mass of 12, 3 hydrogens with a relative atomic mass of 1, and so on and so forth. We find then our total mass of product to be 32 grams. So in our equation for atom economy, we have 32 divided by our total mass of reactants. We can now calculate the total mass of our reactants. Since in this reaction we only have 1 mole of all of our reactants, we can simply say that our total mass of reactants is 16 plus 18. This leaves us with a sum of 32 divided by 34 times 100 and an atom economy of 94%. We must now repeat the same steps for process 2, the incomplete combustion of methane. We already know that the gram formula mass of methane is 16 grams, and oxygen O2 gives us 32 grams. As previously calculated, we know that methanol has a GFM of 32 grams as well. Therefore, our atom economy is 32 divided by 1 mole of methane, so 1 times 16, plus this time we have a half mole of oxygen, so a half times 32. We therefore have a sum of 32 divided by 32 times 100, and therefore an atom economy of 100. From these calculations we can clearly see that the incomplete combustion of methane is the more efficient process. Question 2 states that an equation for the formation of silicon nitride is shown, and we have to calculate the atom economy for the formation of silicon nitride. Again, we must first identify our desired product, which is here, the silicon nitride. And in this question, they've actually already given us a gram formula mass of each of our products and reactants. So we can say that atom economy equals 1 mole of silicon nitride divided by, this time, 3 moles of silicon chloride and 16 moles of ammonia. Apologies, let's put that value in there. This sum therefore becomes 140.3 divided by 510.3 plus 272 times 100. And once we have done that on our calculator, we will find the answer to be 17.93. Therefore, our atom economy for this reaction is 17.93, which is rather low. It is unlikely that we would choose to proceed with this reaction. As previously discussed, atom economy and percentage yield can be compared to give an indication of the economy of a process. To do this, we use the information in the equation to complete both these calculations, and we then compare our results. Here is an example of the type of question where we would have to compare atom economy and percentage yield. Esters can be used to make alcohol by hydrolysis. 4 grams of ethanol is produced from 10.2 grams of ethyl propanoate. Is this a suitable reaction for producing alcohol? Our first step would be to calculate atom economy. To do this, I'm going to quickly rewrite these formula as molecular formula, as this will make calculating the gram formula mass easier. Our desired product is ethanol. So here we can work out the gram formula mass, and this is 46 grams. We have 1 mole of both of our products, so we can simply work out their gram formula mass. Here the sum is 46 divided by 120 times 100, which leaves us with an atom economy of 38.34%. So quite a poor atom economy showing from this question. Let us look at the percentage yield. To calculate percentage yield, we need our actual yield divided by the theoretical yield times by 100. The actual yield is given to us in the question. We are told that we can produce 4 grams of ethanol. And the theoretical, we must work out from the calculation. To do this, we need to work out the number of moles of ethanol that are actually produced. So here we have a 1:1 mole ratio, but we need to work out the actual number of moles that we have, and we can do this by working out the number of moles of our reactant. we are told that we have 10.2 grams of ethyl propanoate from the question, and our gram formula mass we've already worked out to be 102, therefore we have 0.1 moles. If we use this to do a mole ratio, we find that we have 0.1 moles of our reactant, our product, my apologies. We can therefore calculate the mass that would theoretically be produced using the number of moles times the gram formula mass. And this would give us a mass of 4.6 grams. Substituting this value into our percentage yield calculation, we can see we now have 4 divided by 4.6 times 100, and this gives us a percentage yield of 86.96%. So from this calculation, we can see that while the reaction has a high percentage yield, it has a very low atom economy, and as such it is not economically viable, and it is unlikely that this reaction would proceed.